tell me, what are we going to do over here?
So, ma'am, the first thing you're going to do is with the a cubed minus a squared over 4, you place it down, then you next to it you put a multiplication sign.
Good. Over 4 multiplied by, and then what should happen?
And then you swap the a squared with the 8.
Correct. So we would then get 8 over a squared. Beautiful. Excellent. What's my next step?
You times the top, and then you times the bottom.
But remember what ma'am's first instruction was when it comes to algebraic fractions.
Oh, you're supposed to
What
factorize.
must we? We're supposed to factorize. Okay, do you want to factorize this part for me? How would we factorize that part? What kind of factorization are we using there?
HCF.
Of course, it's HCF, 100%. What is my HCF there?
A cubed.
Well, a cubed is not going to go into a squared. So rather than taking a cubed out, which one should we take out?
A squared.
We should take out the a squared. Okay, otherwise we're going to end up with a squared divided by a cubed, which is kind of very hard to solve and it doesn't look very nice. But if we take out a squared, remember what we're going to do, my sweetie. We're going to divide this part by a squared and we're going to divide that part by a squared. So if I've got a cubed divided by a squared, what's that going to give me?
A.
Good, it's going to give me a. And then I've got negative a squared divided by a squared. What should that give us?
Don't they cancel each other out?
They do, but they don't just disappear. So if they cancel each other out, what are they going to give us?
1. Negative 1.
1. Negative 1. Excellent. Good. Over 4. Now times that by 8 over a squared. Now, let's look at our fraction. Do we see anything on the top and at the bottom that are common that we can cancel?
A squared and a squared.
Correct. A squared and a squared. Good. And I could also make my numbers a little smaller. How can I do that? How can I cross cancel my numbers?
By finding a common factor, then dividing that common factor with both.
Correct. Okay, what is that common factor?
2.
Okay, if I divide over here by 2, I'm going to have 2 left. And if I divide here by 2, I'm still going to have 4. But there's still another number that can go into both of those, right?
Yeah, with the 4 and
What
2.
number can? Yes, into 4 and 2. What other number can go into 4 and 2?
2.
2, good, yes. Well, yes, 1, but let's start with 2. If I divide 2 by 2, I'm going to end up with 1 here. And then if I divide 4 by 2, I'm going to end up with 2. Right. So what do I actually have left at the bottom?
1.
I have 1 left. What do I have left at the top?
In brackets, a minus 1 and 2.
Good. I'm
2.
just going to put it up here on the front because it means the same thing. We're multiplying them. Yes. Okay.
Yes,
and all of that is over 1, but I don't have to write the over 1 part because any fraction over 1 is just that fraction. But that's the answer I'm looking for. Well done, Mandisa. Okay. Remember, ma'am's number 1 rule, we must always factorize everything. Okay. So make sure you're checking for that first. All right. Okay, good stuff. All right, let's have a look at this next one over here. Let's look at number 2. I'm just going to ask if you guys want to pop your answers in the chat for me. What kind of factorization are we looking at over here in this first example over here? Who's got an idea for me? You can pop your answer in the chat for me. Melissa says HCF. I don't know if there's an HCF. I don't think x squared and x and negative 6 have anything in common, but Tseho does say trinomial. And I agree because we have 3 terms, right? So this is going to be trinomial. Right? What about down here? What are we seeing over here? And Mandisa, your answer would be correct in this case. What are we looking at down here? Definitely looking at HCF over here. What about up here? What do we see over here, guys? Good, it's dots. It's a difference of 2 squares. So this is going to be dots. And down here, what kind of factorization are we seeing here? Anybody? Somebody? Who's got an idea for me? Correct, Kat. That's it. Correct. It's HCF. Excellent. Okay. So we now know how we're going to factorize each of these. And so we can do that. Okay. At the top, I've got a trinomial. So I'm going to open 2 brackets. I know that one of my brackets will have a plus, and then I know that a plus times a minus will give me a minus. So there'll be a minus in this bracket as well. X and X here. I need factors of 6 or -6. Well, factors of 6 that are going to give us +1 when subtracted. So I can think of +3 and -2. And that's how I factorize my trinomials. Right, at the bottom, I know that it's HCF. The highest common factor between 2x and -8 is 2. So I'm going to take 2 out as a common factor, and I should get x minus 4 left. Multiply all of that. Let me just multiply all of that by my dots at the top. So I'm going to open 2 brackets over here. I'm going to get x plus 4 and x minus 4 over, and at the bottom over here, I'm going to get x out as a highest common factor. So I'm going to end up with x minus 2. And then I can start looking around and I see things that can actually cancel one over the other. So I'm going to then cancel x minus 4 and x minus 4, x minus 2 and x minus 2. Now there's absolutely nothing else that I can cancel there in none of them at the bottom or at the top. So everything that's left is the answer. So I'm going to get x plus 3, x plus 4 over 2x. All right, over 2x. And that's the final answer that we're actually looking for, this answer over here. All right. Okay, and that was just the beginning. Welcome, grade 10s. For those of you who joined us a little late, we were just starting with our While You Wait. If you're joining us for the very first time, welcome to Maths Live. It's great to have you guys with us. Please do let me know in the chat if you're joining us for the very first time. I'd like to give you a nice big welcome. All right, we're going to get started on today's lesson. We did start it last week, Wednesday. We were talking about adding and subtracting fractions. So we're going to continue with that. Okay, I'm just going to remind us over here, whenever we're adding and subtracting, we need to find the what. What did we say that we need to find when we're adding and subtracting fractions? You've known what it is since grade 6, grade 7, correct, that's it. Excellent. We need to find the LCD, the lowest common denominator. And again, because we know exactly what it is that we're doing here, we know that we have to factorize the bottom in order to know that over here. All right, so if we look at this first part that we have over here, we've got x plus 3 and 3 plus x. Now, we know that there's a minus in between them, so that tells us that there needs to be an LCD. What is my LCD going to be, guys? Who's got an idea for us? What would our LCD be here? Not 9, Mandisa. Remember, my answer must have an X in it. My LCD must have an X in it. Okay. What are we thinking, guys? Between x plus 3 and 3 plus x, what would my LCD be between those two? Correct. Okay, somebody named 27682. You need to tell me who you are so I can change your name for you. But somebody says x plus 3. X plus 3. Now, the question when we are finding our LCD is we need to check if x plus 3 will go into that denominator and if x plus 3 would also go into that denominator. I'm going to ask you guys in the chat, tell me yes or no. Do we agree that x plus 3 will go into both denominators or no? What do we think? Yes or no? Will it go in? Will x plus 3 go into both denominators? What do we think, guys? Sia says yes. Mandisa also says yes. Okay. What about, why didn't we include, can somebody tell me, why did we only use x plus 3? Why didn't we also say 3 plus x? Because that one is x plus 3 and this one is 3 plus x. Hello, Palisa. Does the order matter? See the order of what? The order of what? And
Hello,
now look,
ma'am.
I'm right. Hello, my darling. What do you
I
think?
think we used x plus 3 because it's also the same as 3 plus x because they are both positive.
Beautiful. And you said it so well. Yes, x plus 3 and 3 plus x are exactly the same thing. And you told no lies. Well done. Yes, 100%. It's because if I said to you guys that I've got 2 plus 3, 2 plus 3 is exactly the same as 3 plus 2. It doesn't really matter which way we put them as long as they're both the same sign and as long as we're adding, because addition is commutative under, whole numbers are commutative under addition. So yes, we should be able to do that. Okay. So I know that my LCD is going to be exactly the same. So I'm going to do this. I'm going to write x plus 3 over there. And then I'm going to go and I'm going to I'm going to compare. This part over here has x plus 3. Is this part missing any part of my LCD? No, it's not. It's not missing anything. It's x plus 3, there's x plus 3. So there's nothing for me to do to the top either. So I'm just going to rewrite the top the same way that I see it. So I'm just going to write x. And then if I look at 3 plus x also isn't missing anything from my LCD. So I don't have to write anything for my LCD. Okay, that means that -2 also doesn't stay. So our final answer is just going to be x minus 2 over x plus 3. All right, so one thing we do need to speak about quickly is restrictions. Okay, restrictions. I'm going to give you guys a sum. Let me give you guys a fraction. If I say to you guys that I have 6 over x, there's a particular number that x cannot be equal to. Who knows what that number is? What number can x not be equal to?
0.
Correct. Ooh, who said that? Wonderful. Is it you, Kat?
Yes.
Oh, okay, lovely. Yes, absolutely. Why can, Kat, tell me, why can x not be equal to 0?
Because I think like it's a math error. Like more when we have like fractions, right? The fractions must be integers. That's all I know. Yeah.
Correct. The fractions must be integers, but we need to remember that 0 is also an integer. Yes, correct. So Morangi is correct. 0 is an integer, but if we put 0 at the bottom, our answer is going to become undefined. It's going to become undefined. So we can't actually have that. We can't have an undefined answer as a fraction. So in this case, x cannot be equal to 0, but it's not really just x. It's not x that we're talking about, right? Mandisa, in this case, it's just undefined, not even non-real. It just doesn't exist. Okay, but there's a reason for that. I'll explain in just a bit. Now, it's not just x. The whole denominator itself cannot equal 0. So if we take this example that we've got over here, right? Let's take this question that we've got over here. If I take x and I make x 0, I'm still going to have an answer because x over 0 plus 3 is just the same as x over 3. That's still going to give me an answer. But the problem is I need to make sure that my denominator does not leave me with 0. So I'm going to ask you guys, what number can x not be? What number is x going to be that's going to give us a problem down here? What number can we replace x with that's going to give us an undefined answer for our fraction? Sia says 1, but if I put 1 in here, I'm just going to end up with x over 1 plus 3, which is 4. And x over 4, that's fine. That's going to give me an answer. So I know that x can be 1. Can we think of another number? Think of which number is going to make the bottom equal to 0. Which number is going to make my denominator equal to 0? Think about it. If I had x minus 1, I know that if I want this to be equal to 0, x would have to be equal to 1. Ah, Palisa's got the right idea. That's it. So in this case, in the case that we've got over here, x cannot be equal to 1 because 1 minus 1 is going to give us 0. So if we want, that's it, correct, Desiree and Desmarie and Palisa, good. If we want x plus 3 equals 0, we know that x needs to be something in order for this to be equal to 0. We now know that x cannot be equal to -3. Because if I get -3 down here, I'm going to get -3 plus 3. That's going to give me 0 down here. And I can't get 0 because that's going to give me an undefined function. Give me a thumbs up. Do you guys understand why ma'am says x cannot be equal to -3? Yes? Are you guys with me here? Excellent, Seho. Well done. Good stuff, Mandisa. All right, I'm going to ask another question. If I had x minus 2, or let me write it as a fraction. Let me write it as a fraction. I'm going to write 4 over x minus 2. Now, Kat, do you want to unmute for me, my darling, and tell me, we said that the bottom cannot be equal to 0. Yes, this part cannot be equal to 0. Agreed?
Yes.
Okay, so what value of x would make the bottom equal 0? Think about it. What minus 2 equals 0? Is it? Think of, okay, guys, do you want to help out in the chat? Put your answer in the chat. Think about it. Which number can I replace here? Something minus 2 equals 0. What is that something? Check in the chat. Balisa's giving you the right answer, my darling. And Mandisa. It's?
+2.
+2, correct, because +2 minus 2 is going to give us 0. And remember, Kat, how you told me that 4 minus 0, 4 divided by 0 is not going to give us an answer. Yes?
Yes. Yes.
That means that x cannot be equal to +2. Do you understand what ma'am's saying now?
Yes.
Okay, so let me give you another example before we run away from this. What if I had 4 over x plus 5? What can x not be equal to?
-5.
Ah, look at you, understanding the things. Correct, x cannot be equal to -5 because -5 plus 5 will give us 0 and then we won't have an answer. Are you seeing what I mean?
Yes, I do, ma'am.
Beautiful, excellent. I'm glad I'm not leaving you behind. All right, I'm glad everybody's on the same page with me when it comes to restrictions. We're going to get a lot more as we go. All right, let's look at our next example. Okay, now this one is a little different. It's a little different, right? I'm going to have to do one of two things. Okay, I'm going to have to choose my LCD very smartly, or I'm going to have to choose both LCDs. All right, now if I say to you guys, what is my LCD here? What would you guys say? You can pop your answer in the chat or you can unmute and let me know. What do we think, guys? Okay, Morangi says x minus 3. Mandisa says x minus 3. Okay, x minus 3. All right, I agree with you. What about 3 minus x? What about 3 minus x? Should I also include 3 minus x? Palisa, I'm not sure where the plus 3 comes from. I don't know if x plus 3 will work in this case because we don't have a plus 3 in the denominator. Okay, so Mandisa says 3 minus x is the same thing. Okay, and I'm going to tell you, no, it's not. All right, it's not. And this is the reason why. Remember that example that ma'am gave you where I said 5 plus 2 is the same thing as 2 plus 5. We agree, right? 5 plus 2 is 7. 2 plus 5 is 7. That's easy enough. But if I then said 5 minus 2, 5 minus 2 is going to give me positive 3, but 2 minus 5 is not going to give me positive 3. 2 minus 5 is going to give me negative 3. It's not going to give me what I want. Okay, so these two denominators are not the same. They're not the same. Give me a thumbs up in the chat. Do you understand why ma'am says that these two denominators are not the same? Are you guys with me here? Yes, everybody okay with that? Good, excellent. Okay, they're not the same thing. All right, Morangi, if I say to you, I've got 10 minus 3. 10 minus 3 is going to give me positive 7. Yes? Now, 3 minus 10, what does 3 minus 10 give me, Morangi? What's that going to give me? It's going to give me negative 7. So are 7 and negative 7 the same thing? Do we have the same thing over here? No, we don't. We don't. So we can't then say that our LCD is just going to be x minus 3, because 3 minus x is not represented by x minus 3. Am I making sense? However, we have learned a rule. Do you guys remember when we were doing common brackets? Do you remember? If I gave you a sum like this and I said factorize, if I said a, and then in brackets I had x minus y plus b, and then in brackets I had y minus x. I can do something in maths to the second bracket to make it look like that one. Who remembers what that is? What can we do? Anybody remember what I can do? Okay, I don't know what you guys call it. In my school, I call it a switcheroo in my classes. Some of you guys maybe call it a switch and flip. I can't remember what you guys, I don't know what you guys call it. All right, so what I can do here, guys, is I can change the sign of that plus b in the middle. I can change that sign to a minus. And then I can switch around these two numbers. That's why it's called a switch and flip. And then I can get x minus y. Give me a thumbs up in the chat. Have you guys seen this before? Have you seen this switch and flip idea before? Anyone? Morangi's seen that before. Alessa's seen it before. We should have. It was a grade 9 concept, yes. Sia says he's never seen it. Okay. Well, Sia, if you're ever factorizing common brackets, which is actually still HCF, we should be familiar with this. Okay. So I want you to stay with me as we do this one. Good, so excellent. All right. So I want you guys to stay with me. Do we notice that x minus 3 and 3 minus x, very, very close to each other? It's just that the two numbers in the one are switched around. They've just been switched around. So what ma'am is going to do, what I'm going to do right now is I'm going to take that minus in the middle over there, and I'm going to change it to a plus, and then I'm going to switch my two numbers around. So I'm then going to make this 3, and I'm going to make that x. So I'm basically going to get x over x minus 3 plus 2 over x minus 3. Now, can we say that our LCD is x minus 3? Yes. Our LCD is x minus 3 because they both are now x minus 3. But we're not done. I need a restriction. Who can remind me? What is our restriction here? What can x not equal? X cannot be equal to what? Which number can x not be equal to? Mandisa, you were right the first time. You were right the first time. Well done. Yes, Sia, correct. Good. That's it. The answer is positive 3. X cannot be equal to positive 3. Because if we get 3 over there, I'm going to get 3 minus 3. That's going to give me 0. So x cannot be equal to positive 3. All right. So now I can put all of them underneath the same denominator. I can go like that. X minus 3 That part isn't missing any part of the denominator, so I can just put the x there. And x minus 3 is also not missing any part of my denominator, so I can just put x2 there. So that's the final answer, x plus 2, x minus 3. Oh, over x minus 3. Give me a thumbs up. How are we feeling? Tell me, do we want to try another example? I have a feeling, I think we should do another example, yes? I want to make sure that we're all okay with this. Yeah, absolutely. Let's try another example, but I'm going to step it up a little bit because I don't want us just to stick with an easy, nice, easy stuff. Let's look at this one over here. All right. Now, before we continue, remember ma'am said our denominators must always be fully factorized. Does anybody notice anything in the denominator where we can factorize? And what kind of factorization we're seeing here?
On the second fraction, the denominator is the difference of two squares.
Ah, beautiful. Well done. Absolutely. Is that you, Kat?
Yes.
Ah, beautiful. This is the difference of two squares. Ah, wonderful. Excellent. So let's put that together. Right. I'm going to go 2x over x minus 3 plus x plus 1. Do you want to tell me, Kat, what goes into both my brackets?
X is going to go on the first bracket and the second one is the first
Good.
term. Then it's going to be 3 because 9 is the square of 3.
Good. So I'm going to have plus 3 and
Minus 3.
beautiful. Oh, well done. Amazing stuff. Excellent. Ah, beautiful. All right. Let's talk about LCD, guys. Let's talk about LCD. I already know that I've got x minus 3, x minus 3. So I know that x minus 3 is going to be part of my denominator. Anything else? Anything else, peeps? What do we think? Okay, I'll let you guys in on the secret. Well, it's not really a secret. The other part of our denominator is going to be x plus 3. Why is ma'am also including, why is teacher Coco also including x plus 3? Who's got an idea? Nobody. Okay. All right. Let me ask a simple question. Let's say, for instance, that x was actually equal to 5. If x is equal to 5, I'm going to get 2 over here, right? Because 5 minus 3 is equal to 2. But over here, I'm going to get 5 plus 3, which is 8, times 5 minus 2, which is 2. 5 minus 3, which is 2. So my two denominators would be 2 and 16. Between 2 and 16, what is my LCD? Between 2 and 16, guys? It can't be 2 because 16 can't go into 2. It's going to give us a fraction. Mandisa, what do we think? It can't be, guys. Remember, the biggest number always needs to be the one that we're catering for. Okay. Yeah. Okay. Sia says 32, and I agree with Sia, but remember, does 2 go into 16?
Yes.
Does 2 go into 16? Yes, it does. So in this case, our LCD could be 16. I'm going to give you guys another example. If I have two numbers, yes, correct, Morangi, it must be 16. If I have 3, if this part of my equation is 3, and this part over here is 12, what is the LCD between these two numbers? Between 3 and 12, what would my LCD be?
12.
It would be 12. Who said that? Mandi says that you.
Yes, ma'am.
All right. Why do we say 12, Mandisa?
Because 12, it can go into itself as well as 3.
Beautiful, because it can go into itself and 3, right? So if we look at our denominators that we've got over here, I already know that x minus 3 is already in here, but that's not the full denominator. What else must also go into my denominator? X plus 3. because x plus 3 must also go into itself. This x minus 3 already goes in here. It's fine. But the x plus 3 must also be represented in the denominator. Give me a thumbs up. Are we all okay with what Mams just said here? Are we all okay with that?
Wait, so ma'am, the LCD,
Mm-hmm.
the LCD in this case would be 3x plus 3.
And x minus 3, both of them. It needs to be both. It must be both, because both of them need to be represented. Remember, we must represent the whole denominator. Okay.
Oh.
Okay, Kat, I'm going to finish this question quickly, and then I'm going to show you another example, and I'll show you exactly what I mean. Okay, so I'm going to do this. I'm going to go equals over here, and I know that my LCD needs to be x plus 3 and x minus 3. I need to represent the whole denominator. Now, if I look at this part over here, this denominator over here is missing x plus 3. So in order to get that to look like the LCD, I'm going to multiply this part by x plus 3. And whatever I do on the bottom, I'm going to have to do on the top as well. So I'm going to go to the top, and I'm also going to multiply the top by x plus 3. So what I actually have over here is 2x, and in brackets, multiplied by x plus 3. Right. Now, I know that x squared minus 9 factorizes to x plus 3, x minus 3. So there's nothing missing from my denominator over here. So I don't have to do anything to the top. I don't have to do anything to the top. I can just leave the top exactly the way it is. So I'm just going to write plus x plus 1. Right. That's the first thing that I'm going to do. Next thing I'm going to do is I'm going to take this 2x and I'm going to multiply it in. I'm going to distribute. Okay, so my final answer, 2x times x will give me 2x squared plus 2x times 3 will give me 6x plus x plus 1 over the whole denominator, x plus 3 and x minus 3. But look at Teacher Coco's forgotten. I need restrictions, guys. What are my restrictions here? What can x not be equal to? X cannot be equal to what?
-3 and -3 and positive 3.
Good. Plus or minus 3. Well done, Mandisa. That's it. Correct. X cannot be equal to either positive or negative 3. All right. So what I'm then going to do over here is I'm going to add my like terms. So I've got 6x plus x. I'm going to add these two. Right. So I'm going to end up with 2x squared plus 7x plus 1 over, and the denominator must stay the same, x plus 3, x minus 2. And I can tell that so many of us are a little bit like, huh, ma'am, what just happened? So we're going to do another example. Yes, let's do another example. All right, here's my next example. Now, look at my denominators. Do I notice anything in my denominators? Yes, Mandisa.
Ma'am, for the... Oh, never mind, ma'am. I just realized. Never mind.
Okay, no worries. No worries, my darling. That's okay. Okay. Let's look at the denominators over here. Do we notice anywhere where we can factorize, guys? And what kind of factorization are we looking for here? Who's got an idea for me? I'll give you guys a hint. This one over here has 3 parts. It has 3 parts. That's it, Seho, correct. It's a trinomial. It's a trinomial. So we're going to factorize this part, and we're going to find what the trinomial should look like. So I'm going to go to the top, x plus 1 over x minus 4 minus 3 over, now that I know it's a trinomial, I'm going to open 2 brackets. And Sia's already factorized it for us. Well done. Sure. All right. Sia says we've got x plus 1 over here, and we've got x minus 4 over here, and Sia is 100% correct. Now, I'm going to ask you guys, now that I have x plus 1 and x plus 1, can I do this? Yes or no? Can I cancel? Because they are common. Can I cancel?
Yes.
Okay, Kat, is that you saying yes?
Yes, ma'am.
Okay, I want to see what everyone else says. What do we say, guys? Kat says, yes, we can cancel because there's one at the top and at the top. I mean, at the top and at the bottom. Do we all say yes? Mandisa also says yes. Sia says yes. Okay. Marangi also says yes. Okay, Desmarie says yes. And unfortunately, the answer is no. Oh no, it's no, guys.
Ma'am,
It's yes.
is it because x minus 4 and the x minus 4 also can they also cancel each other out? No.
No, they can't. They're also both in the denominator. Sia's like, I meant no. All right. Here's the reason, my darling. The only time you cross cancel, let's say, for instance, I give you 8 over 2 times 4 over 3. I can cross cancel, yes. That is going to give me 1. That's going to give me 2. Let's make this just to make things easier. And then I can say that's going to give me 2 and that's going to give me 1. Right. The reason I can cross cancel here is because there's a multiply in the middle. There's a multiply in the middle. We said whenever we see two fractions, if I have a fraction and it has a plus or a minus in between the two fractions, can we cross cancel? No, we can't, because we've got a plus or a minus. We must always look for a what? What must we always look for?
Multiplication and addition.
Think about what we've been doing in all the other questions. What must we look for?
The multiplication sign. LCD.
The multiplication sign. Mandisa, what must we look for?
The LCD.
An LCD. Well done, my darling. That's the correct answer. The only time we cross cancel is if there's a multiply in between. If we don't have a multiply, if we have a plus or a minus, we must always look for the LCD. Spot on. Well done, Mandisa. That's it. LCD. Now, let's look at the numbers that we've got over here, guys. I've got x minus 4, and then I've got x plus 1 and x minus 4. What is my LCD going to be between these three brackets? What is my LCD going to be?
X plus 1.
I heard that, x plus 1. Somebody whispered it. Beautiful. X plus 1 and?
X minus 4.
Well done, Marani. And x minus 4. That's it. Beautiful. Those are the two things that are missing. All right. We're not done. Give me restrictions, guys. What restrictions do we have here? X cannot be equal to
-1 and +4.
Beautiful. That's it. X cannot be equal to -1 and X cannot be equal to +4. Well done. Amazing stuff. Excellent. All right. I hope I'm not leaving anybody behind here. Okay. I hope you guys are all with me. Now we're going to draw a long line like that, and I'm going to write x plus 1 and x minus 4. Yes, Sia, absolutely you can. Yes. And x minus 4. We're a small enough group that we can do that. All right. Okay, so now let's go back to how we're going to answer this question. Now, if I look at this part over here, my denominator over here is missing what? What part of my LCD is missing from x minus 4, guys? What am I missing? Good, I'm missing x plus 1 over here. So if I'm going to multiply the bottom by x plus 1, I'm also going to multiply the top by x plus 1. So I'm going to end up over here with x plus 1 multiplied by x plus 1. Now, over here, am I missing anything from my denominator over there? Am I missing anything?
No.
Nothing's missing. Nothing's missing. Nothing's missing. So I don't have to change the bottom. Therefore, I don't have to change the top. So I've still got -3 on the top. All right. So, and there goes another one. I'm going to put some space in between this one and us. Yes, sir. Yes, ma'am. I'm hearing a voice.
How come like the numerator has x plus 1 and x plus 1?
Okay, so remember this part already had x plus 1, right?
Yes.
The fraction itself already had x plus 1. Now, when we went and found our LCD, we said that our LCD is x minus 4 and x plus 1. So we can tell that this first fraction is missing what? What is this first fraction missing in the denominator?
X plus 1.
Good, it's missing x plus 1. So if I multiply the bottom by x plus 1, where else must I also multiply?
At the top.
At the top. So you see how when I add the x plus 1, I get x plus 1 and x plus 1.
So like, we're going to
I
take
mean,
the numerators only.
yes, because the denominator is already written the same.
Oh, okay. I didn't understand that part. Thanks.
Okay, so remember, as soon as we've got a denominator, then we can leave the denominator the same for both of them, and then we just change the top. Okay. I hope that's helpful. Desmarie says, ma'am, how did they become, yes, correct. The reason why it's negative is because of this negative over here. That negative belongs to this part. Okay, it is. It's because of that minus. All right, Desmarie, it's the same as in maths if I decide to write negative 3 over 4, or if I write negative 3 over 4. These two things mean the exact same thing. If the negative is in front or if it's at the top, it means the same thing. All right, it's exactly the same. All right, now over here, I'm going to do FOIL. I'm going to do top, top, bottom, bottom. I'm going to end up with x squared plus 1x, and at the bottom, plus 1x plus 1 minus 3. Ooh, I forgot the plus 1. Minus 3 over my denominator, x plus 1 and x minus 4. And then I'm going to simplify. Then I'm going to get x squared plus 2x minus 2 over x plus 1 and x minus 4. Now, I don't want us to leave this here. I want us to try another example. I'm going to give you guys another example, and I want you guys to please just walk through it with me because I don't want to leave you guys behind. Okay, let's go through this together. All right, here's your next example. I'm going to give you x plus 3 over x plus 2 minus 4 over x squared plus 5x plus 6. All right. So who wants to tell me what is the first thing we're going to look for? What's the first thing we're going to do?
Ma'am.
Anybody got any ideas? Yes. Yes, my darling.
Ma'am, first you have to factorize. Do you fact? Yeah.
Oh,
So with the
good.
in the second sum at the bottom, that's a trinomial.
Good. It's a trinomial. Excellent. Right. So let's go ahead and do that. Okay. So I'm going to get x plus 3, x plus 2 minus 4 over, and then I've got 2 brackets. What goes in each of these brackets?
X, and both of them will have a positive sign, a plus sign.
Good. Positive and a plus, got a plus and a plus. And then what about my sum, my numbers?
2 and 3 or 3 and 2.
It didn't matter. Good. 2 and 3. Okay. Sia, which question? Would you like to let me know which question? Oh, you mean the one at the top? It's unfactorizable. We can't, it's unfactorizable. You won't be able to factorize it. Okay. It's not factorizable, my darling. Okay. All right. So let's talk about this one over here, and then we'll come back to that one quickly. Just now, Sia. All right. So if we look over here, guys, what is my LCD between these two going to be? What is my LCD going to be equal to?
X plus 2, x plus 3.
Beautiful. X plus 2, x plus 3. 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 X and x plus 3. Excellent. So I'm going to write all of this underneath one thing. So I'm going to write here equals, and I'm going to write one big denominator, x plus 2 and x plus 3, right? Then we're going to go over here. Let's go to that first bracket. My denominator over here is only x plus 2. What is it missing? What is this part missing?
X plus 3.
Good, it's missing x plus 3. So we're going to add x plus 3 here. And whatever we do to the bottom, we add x plus 3. So at the top, I'm going to end up with x plus 3 times x plus 3. Now, this part over here, is anything missing from my denominator over there? Nope, I'm not missing anything. So I don't have to do anything to the top or to the bottom. I'm just going to write minus 4. Minus 4. And then we can do a little bit of FOIL. Okay, we're going to do first outer, inner last. I'm going to end up with x squared plus 3x plus 3x plus 9 minus 4. All of this over x plus 2 and x plus 3. Right. Then we're going to clean up the top. We're going to add like terms at the top. Okay, so we're going to get x squared plus 6x, 9 minus 4 will give me plus 5 over x plus 2 and x plus 3. Now, we can factorize the top. We actually can. We can, but it's not really going to change anything if we factorize the top here. I mean, we can do it. I'm going to get it. It's a trinomial, so I'm going to get 2 brackets, and they're going to give me x plus 5 and x plus 1 over x plus 2 and x plus 3. But now, there's nothing I can do beyond this point. Okay, give me a thumbs up if you're okay with how ma'am has solved this sum. Give me a thumbs down, or you can say, ma'am, another example. What are we thinking? Because I do have another example here. What do we think, peeps? Morangi says another example. That's fine. Okay, another example. Okay, great. Okay, let's go ahead and do that. I'm going to give you guys another example over here, right? So I'm going to give you guys x over x squared minus 25 plus x plus 2 over x squared plus x minus 20. All right. Okay, now let's look at our denominators. What do we notice in our denominators, peeps? Yes, Mandisa.
Ma'am, in the first one, that is the difference of 2 dots. I mean, 2 squares.
2 squares, correct. Difference of 2 dots,
And
yes.
Yeah. And then the second one is a trinomial.
Excellent, trinomial. Beautiful. So let's factorize, guys. Let's go ahead and factorize. Sure, Mandisa, you're on fire today. I just have to say, every single answer I've needed, Mandisa has been to our rescue, guys. She deserves all the flowers. She's just been doing the things today. Okay, now if we factorize the bottom over here, we're going to get x plus 5 and x minus 5 plus x plus 2 over, now this is a trinomial, so I'm going to open 2 brackets. You guys need to tell me what goes in these 2 brackets. Tell me, guys, what goes in my 2 brackets.
Ma'am?
Yes.
Is it not x plus and x minus is it
and then what 2 numbers are going to give me x? Remember, this is 1x. Good. So
5 and 4.
Good. X plus 5 and x minus 4. Good. Beautifully done. Excellent. I know she's doing the most. All right, let's talk about LCD. Now, remember again, guys, my entire LCD needs to be represented. So what are we looking at in terms of LCD? What numbers are we going to get, or what values are we going to get there for our LCD? What are we thinking, peeps? Good. Morangi says x plus 5. Agreed. What else?
And x minus 4.
Beautiful. And x minus 4. I say we're not done. There's still one missing.
Oh, x minus 5.
Ma'am, is it x minus 5?
There we go. There we go. I heard that. X minus 5. Sia, was that you? You and Mandisa
Yeah,
got it.
ma'am.
X minus 5.
Both of
Good.
us.
Beautiful. Well done. Well done. Excellent stuff. I'm glad we've got it. Good. So let's go write our LCD out. Okay. Now we've got all of this over x minus 5. Ooh, x plus 5. X minus 4. X minus 5. Tell me my restrictions, peeps. X cannot be equal to what?
It cannot be minus 5
Minus 5.
and plus 5. Or also plus
Good.
4.
Positive 5 and
Plus 4.
plus 4. Well, that's it. Beautiful. Excellent stuff. Well done. All right, let's go to the top now. If we look at this part over here, this part is missing the x minus 4 from my denominator. So if I multiply the bottom by x minus 4, I need to multiply the top by x minus 4. I'm just going to write this the other way around over here. I'm going to write the x first. So I'm going to get x, open brackets, x minus 4, plus x plus 2. This part of my denominator is missing the x minus 5 part. So I'm going to multiply this part by x minus 5. What I do to the bottom, I'm also going to do to the top, x minus 5. Right, so I'm then going to have x plus 2 multiplied by x minus 5. All right, and now we can do a little bit of distribution, a little bit of FOIL, top, top, bottom, bottom, multiply all of that out. So we're going to get x squared minus 4x plus, let's do some FOIL over here. I'm going to get x squared minus 5x plus 2x minus 10, all of this over x plus 5, x minus 4, and x minus 5. And then we're just going to add like terms at the top. Okay, I know I've got x squared plus x squared. That is going to give me 2x squared. I'm going to get 2x squared. And then negative 4x minus 5x will give us negative 9x, plus 2x will give us negative 7x, minus 7x minus 10 over my denominator, x plus 5, x minus 4, and x minus 5. Give me a thumbs up. How did we feel about that one? Yes, thumbs up, thumbs down. Are we kind of sort of getting it? How are we doing, guys? Are we all good? Sia says, great. I think Sia's finally got it. Those of us who needed more examples, how are we feeling? Beautiful, Palisa. Thanks, Mandisa. Morangi, how are we doing? Kat, how are we doing? Step by step. All right, I understand. Okay, I want to give us a little bit of homework, okay, because the lesson is actually over. The lesson is actually over, but I do want us to go and try some of these ourselves. Okay, I know that they're named very funny. Okay, that is not supposed to be number 2. That's supposed to be number 1. I'm glad. All right, so I want you guys to take a screenshot of this one over here. It's not number 2. It's not supposed to be number 2.